Welcome to the Parallelogram Formative Review. Let's solve some problems involving parallelograms. Alright, so here we want to solve for x and y in the parallelogram. Alright, so let's remember some characteristics of the angles in a parallelogram. So first of all, opposite angles of a parallelogram are congruent. The second characteristic of angles in a parallelogram is that consecutive angles are supplementary. And we know the word supplementary means adds to 180 degrees. All right, so let's use those two to solve for our missing variables. All right, so opposite angles of a parallelogram are congruent. If we look at the diagram, these two angles here are opposite one another. Right? They are on opposite sides of the parallelogram, from corner to corner. So we could solve for x by setting the two angles equal to one another. In other words, 5x equals 125. And then just divide both sides by 5. X is 25. And that's all there was to that part. Now we want to solve for y. Now if you notice, these two angles here are consecutive angles. They're one after the other. They're not across the parallelogram. They're next to each other in the parallelogram. So that means those two angles are supplementary. So we could add the two angles together, set it equal to 180, and we can solve for y. So 11y plus 125 equals 180. Let's subtract 125 from both sides. And that means 11y is 55. Divide both sides by 11, and y is 5. Now you might wonder, would it work if we used the other pair of consecutive angles, these two here? And yes, it would work. We would just have to plug in for x. All right, so let's just see if that works. Let's find out. All right, so we'd have 11y plus 5x equals 180. Well, x is 25, and 5 times 25 is 125. And that's exactly what we have over here. All right, so we would get the exact same answer if we finish solving out. All right, so just remember, opposite angles of a parallelogram are congruent. Consecutive angles are supplementary. Let's solve another problem. Always true or not always true? Here we have some facts about, or here we have some statements, I shouldn't say facts, statements about our parallelogram here, parallelogram ABCD, and we want to identify whether these things are always true or not always true. All right, so let's take a look at our first statement. AM is congruent to BM. Now, by the way, these should have the line segments above, but I can't type them in that way, and they're probably going to come off as soon as I move them, so I can put them in at the end. All right, so AM congruent to BM. Well, is that always true? That's not always true. It's sometimes true, right? And as we're working with special parallelograms, you'll find out that's true for a rectangle, it's true for a square, but it's not always true. So we're going to move AM congruent to BM over there, because those two segments are not always congruent. AB is congruent to CD. Well, that's the sides in our parallelogram, and those are opposite sides. And we know opposite sides in a parallelogram are always congruent to one another. All right, so let's move this one over here. And I'm going to just write underneath this one, opposite sides of a p-gram always congruent. Angle ABC, so that's angle ABC is right there, is congruent to angle BCD. Well, that's not true all the time. We just learned in the last side that angle ABC plus angle BCD would add to 180. So those two angles aren't going to be true, aren't going to be congruent all the time. They're only going to be congruent if they both happen to be 90. Because that's the only two values that add to 180 and are equal to one another. So that's not always true. And actually, I'm going to leave a space here because I'm going to explain why about AM and BM in a little bit. But let's add in here why that's not always true. All right, so only true if all angles are right angles. So if they're all right angles, that would be true. But otherwise, not true. Couldn't get my S in there. Guess that's too far over. There's no hope. All right, we don't need this. All right, let's look at the next one. AB parallel to CD. Well, that's opposite sides of a parallelogram. And we know opposite sides of a parallelogram are always parallel. So that's a true. And let's write in here, opposite sides. By the way, if you want, you can take notes. Similar questions are on the formative of a p-gram. Always parallel. All right, let's look at the next one. AD, and so that would be this side over here. And since it says congruent, let's just put a congruent mark in it. Whoops, we lost our D. All right, so AD congruent to CB. Well, that's also opposite sides of a parallelogram. All right, and we know that they're always congruent to one another. So let's just add AD congruent to CB right over here. All right, because that's the exact same reason opposite sides of a parallelogram are always congruent. Now let's look at the next one. AC congruent to BD. Well, that would be the diagonals here. I'll try to draw a straight line. Not very straight, but there we go. That's better. Now, are those diagonals always congruent? Just like those pieces aren't always congruent, the diagonals aren't always congruent. And actually, the diagonals are only congruent if the angles are congruent. So that's going to mean we'd have to have 4 right angles. And we know the parallelogram doesn't have to have 4 right angles. So the diagonals are not always going to be congruent to one another. AD parallel to CB. Again, those are opposite sides of our parallelogram, and we know that opposite sides of the parallelogram are always parallel. So we can move that over. AD, so that's this one here. So let me get rid of these lines. You won't know which side I'm talking about. You get them all mixed up here, all those lines. AD, which is this one, congruent to AB. Well, those sides don't even look congruent. Although it's just a model, right? We shouldn't go by the diagram to determine whether something is true. Right? We have to use our knowledge of parallelograms. But that's not always true. As a matter of fact, that would only be true if all sides are congruent. And all sides of a parallelogram don't have to be congruent. Right? We got 2 more. Angle BAD. Oh, let's get rid of this because they're not congruent. At least the other marks, sides were congruent. Angle BAD. So angle BAD is this angle here. Oh, let's get rid of this because these angles aren't congruent. Angle BAD congruent to angle DCB. Now that one is true. Because we know that opposite angles of a p-gram are always congruent. And then we have one left. Oops. And he just wants to be difficult. Our last one, AM congruent to CM. Now, AM is not necessarily congruent to BM, but AM is congruent to CM. And that's because diagonals of a parallelogram, a p-gram, are always bisected. They divide, so each diagonal divides the other into 2 congruent parts. So I hope that helps you know what things are always true and not always true about a parallelogram. Okay. What else would need to be true to prove EFG was a parallelogram? Well, I noticed from our diagram that EF is congruent to HG. Right? And that's not quite enough. If you remember over here about our things that are always true for a parallelogram, right, we had a pair of sides congruent. We know that opposite sides of a parallelogram are always congruent. Right? So we would need EH to be congruent to GF. And then we would have both pairs of opposite sides of a quad congruent. But is this the only way to prove that's a parallelogram? Is there another way we could still prove it, this is a parallelogram without knowing that pair of sides was congruent? Well, we actually have one other way. So if EF so let me write we need. So it's clear it's not already given. We need EF to be parallel to HG, and then we would have one pair of sides of a quad, both parallel and congruent. So remember, there are 6 ways to prove a quadrilateral is a parallelogram. One is both pairs of opposite sides of a quadrilateral are congruent. Another is one pair of let's just say opposite. One pair of opposite sides of a quad, both parallel and congruent. We could also have both pairs of opposite sides of a quadrilateral parallel. That wouldn't work in this case because we weren't given any pairs of sides were parallel. We could also use one angle of a quadrilateral supplementary to both consecutive angles, and there's one other way, and I think it's in the next problem. So which method could be used to prove the figure was a parallelogram? So notice we learned 2 slides ago that parallelograms have both pairs of opposite angles congruent. And if we look, we have both pairs of opposite angles congruent. So we could prove that this figure was a parallelogram because both pairs of opposite angles of a quad are congruent. Now it does take both. A kite has one pair of opposite angles that are congruent. So we do have to have both, but in this case we have both. Which method could be used to prove the figure was a parallelogram? So I left off one last method because I knew it was on this last problem. Notice that we have 2 diagonals. Let's just call it AC. Notice AC is divided into 2 equal parts where those 2 diagonals intersect. Now we won't try to put a point there. And BD is divided into 2 equal parts where those 2 diagonals intersect. That means that if the 2 diagonals are divided into 2 equal parts, that means that both diagonals are bisected. So we could prove that the figure here, this quadrilateral, was a parallelogram because both pairs of, got used to writing the word opposite, both pairs of diagonals, both pairs, there's not pairs. After you write both pairs 3 times, both diagonals, I did not hit that. Not even touching it. Don't even know how a K came up. Both diagonals are bisected. Alright, so if you have a quadrilateral, maybe I should put up a quadrilateral. Although if there's only 2 diagonals, it has to be a quadrilateral. But both diagonals of a quad are bisected. So that proves that this is a parallelogram. That's a method. So there's all 6. Right? Both pairs of opposite sides parallel would prove a quadrilateral is a parallelogram. Both pairs of opposite sides congruent proves a figure is a parallelogram. Both pairs of opposite angles congruent proves a quadrilateral is a parallelogram. Both pairs of both diagonals of a quadrilateral being bisected proves a quadrilateral is a parallelogram. Which one did I miss? One pair of sides opposite sides, both parallel and congruent, or one angle that is supplementary to both consecutive angles, are the 6 ways to prove a quadrilateral is a parallelogram. Now, there is a question on the formative that is very, very similar to one of the proofs that we did, proving the features of a parallelogram. And actually, specifically, proving the ways to prove a figure is a parallelogram. So, in other words, one time we proved that if we had both pairs of opposite sides of a quadrilateral congruent, that would prove that the figure was a parallelogram. One time, that's this one here. All right, so here we proved both pairs of opposite sides of a quadrilateral are, no, on this one, I'm sorry. We proved that if one pair of opposite sides was both congruent and parallel, that would be a parallelogram. We used this method to prove it was true, but when I say this method, this one here, the method we were actually proving was that if we knew that one pair of opposite sides was parallel and congruent, that we could actually prove the figure to be a parallelogram. So we proved the methods to prove a figure is a parallelogram. So remember how we did this. We got a pair of triangles congruent, and then we could use CPCTC to get other parts of those triangles congruent and actually use one of the other methods that we had already learned to prove a figure was a parallelogram. Right? So just take a look. They're in your notes, and I also put them here just so that you could review them. Right? So here we proved that if we knew both pairs of opposite sides were congruent, that indeed would make a parallelogram. And in this proof, we proved that if both diagonals were bisected, that would also have to be a parallelogram. So you can read over those, you can pause these and look at them. I'm not going to go through them again because we've already done that. All right, so that's the end of my podcast. Thanks for watching. I hope this helps you do really well on the parallelograms formative. Bye for now.